These are the notes for 7.3. This was the section where you started talking about congruence. So congruence is when you have exactly the same size and shape. And we talk about angles and lengths having the same measure. Sorry, angles and sides having the same measure and length. And the symbol we use for congruence is an equal sign with a squiggle on the top. So our first example of something that is congruent is when I have these two triangles, ABC and KNG, and they are congruent because the corresponding, the parts that sort of match up are congruent. We have 3 tick marks for this side, 1 for this side, and 2 for this side. And the reason why we use different numbers of them is because we want to indicate that only side AC is congruent to KG. It's not congruent to NG and KN. And then I have my angles marked, 1 tick, 2 tick, 3 tick, 1 tick, 2 tick, 3 tick. And then I write the congruence statement. Triangle ABC is congruent to triangle KNG. Please note that the order in which we wrote these matters. I started in this triangle, I went ABC. You can start anywhere, but when I started with A, I started with the angle that had 1 tick mark, which means when I finish my congruence statement, I need to start with the angle that has 1 tick mark. So I went from 1 tick mark to 3 to 2, which means I also have to go in the same order, 1 to 3 to 2. We have an example of something that is not congruent. We have 2 quadrilaterals. They look not congruent, but really the reason why we know they're not congruent is because we only have 1 side marked congruent and 1 pair of angles marked congruent. And you'll actually even notice that these angles don't look congruent in terms of measuring, eyeballing it, but remember, it's the marking that matters. It's almost like you have to assume that my drawing is so horrific, which it is, that you have to only pay attention to the markings. That's what I tell you. So these are not congruent. I don't say anything about these other 3 angles or the other 3 sides, so I don't know anything more. Now, corresponding parts. This gets at sort of some of the congruence idea that we were just talking about. Although we can say that sides are corresponding even if they aren't exactly the same length. So we could talk about the fact that we have L and M sit at about the same place as A and G, even though the second quadrilateral is kind of moved around a bit. So we would say that A and G is corresponding to L and M. We could then say that MN corresponds to AJ. They look about the same length. They may not be exactly the same because we don't have the congruence markings, but they look about the same. So that's what makes them the corresponding. So then I have KN, and that looks like it's pretty similar to JI. And then lastly, KL looks like it's pretty similar to GI. So those are corresponding sides. We also have corresponding angles, so we'll name those. It looks to me like angle L corresponds pretty nicely to angle G. Angle M corresponds pretty nicely to angle A. Angle N corresponds pretty nicely to angle I. And angle K corresponds pretty nicely to angle J. And so these would be our corresponding angles. Again, they don't have to be congruent, they just have to sort of look like they're sitting in about the same spot. So look like they possibly could be congruent. But I don't know for sure because there are no markings on these pictures. Now, we've been using some notation on our drawings that I just want to formalize here. So a couple of different things. You've heard me say the words line segment AB. And we write that as AB with a line on the top. And it looks like a line segment. A line has arrows, goes on forever, line segment stops. We've also been talking about angles. Here we talk about angle A, and it refers to the place where the two rays, A and G and A and N, meet. So angle A, we're talking about where the vertex of the angle is. Now, we can label this angle not only as angle A, we can also call it angle NAG or angle GAN. This comes into play and is really important when you're given a figure like this, where you actually have three angles hiding here. You have the little one below, you have the bigger one on top, and then you have the one that goes from the bottom all the way to the top. So when that happens, we have to use the three letters. So I'm going to call my first little angle here at the bottom NLM. My second angle that's a little bit bigger, angle MLK. And my third angle, which is the whole big angle, NLK. Now I want you to notice here that all three of these angles have L in the middle because all three of them have L as the vertex. But the letters on the outside, around the L, around the vertex, specify how far I should go. Should I go from N to L to M, so this angle, or should I go from N to L to K, the whole big one, or should I go from M to L to K, the bigger of the two cut-up ones? Lastly, we've been using these marks already, but I want to make it very explicit. When we talk about congruent line segments and angles, we mark them on our drawings. So either I tell you by using the symbols, segment AN is congruent to segment BU, or I could give you a picture in which I mark that they are congruent. If I gave you just the picture without the marks, you couldn't tell me anything. If I gave you the picture with the marks, you could write this statement. If I gave you this statement without the picture, you could create the picture. So let's look at that for the angles. If I gave you just this picture of the angles, you couldn't tell me anything more than the names of them, angle G and angle H. However, because I gave you this statement where I said angle G is congruent to angle H, I can mark these two angles as congruent, which means I could have started now with the picture and you could have written the statement.